Um, this is a little demonstration called Is All the Lead Out? And again deals with solubility equilibria. And one of the things is that different slightly soluble materials have different KSPs. Those KSPs indicate the relative solubilities of everything. And this again has environmental implications. One of the things that we're going to look at is the lead. Okay, so this is a lead nitrate solution. Put in some lead nitrate. And to this, I'm going to add some potassium chloride solution. You can use sodium chloride, potassium chloride, or ammonium chloride. It should be something that's not going to be interfered with. And you can see we're going to get lead chloride precipitating out. Of course, it takes a while for this to settle, but if you've added enough chloride, you're going to reach an equilibrium in which the addition of any more chloride will not create any more precipitate. It looks as if all of the lead has come out. And in this system, we have the lead chloride at the bottom, and I've added more potassium chloride, and you can see there's no further precipitate. So one might think that all of the lead has precipitated out. And what someone might do is say, oh, look at this lead chloride. It would be safe to dump in a place like Minamata Bay in Japan. And it would be totally safe. You can see it is insoluble in water. But is all of the lead out? What we're going to do is now add some potassium iodide. And when we add the potassium iodide, we get a yellow precipitate. That precipitate is lead iodide. You can see the lead iodide is up here, lead chloride down here. What has happened? Well, all of the lead is not out. The solubility product constant of lead chloride is much, much less than that of lead iodide, being 10 to the minus 5 versus 10 to the minus 9. And so we can continue to add the potassium iodide, and we continue to get the yellow precipitate. Okay. That will mix in and settle. We'll give that time to settle, which we did in this case. Okay, and you can see that we've got the white lead chloride at the bottom, the yellow lead iodide, and so let's add some more potassium iodide. See, we get no more yellow precipitate. So what does that indicate? Well, that indicates that as far as iodide is concerned, all the lead is out. But is all the lead out? Now, normally, if you look at this demonstration, the next material to be added would be sodium sulfide solution. It stinks like rotten eggs, so we're not going to use that. What we're going to use is something not quite the same, because you get a black precipitate with the sulfide. We'll get another white precipitate. We're going to add the iodine, and this is have taken out enough lead so the iodine is not going to show up as the precipitate as it should today. Okay, so the sulfide does work better, but believe me, there's still lead there, and as indicated in the silver acetate experiment, if there's something that causes the lead to be removed, or mercury to be removed, in the case of mercury, through some bacterial action, all of this will dissolve, will go back into the solution and contaminate the food chain if this gets out into the environment.